Welcome back to another video. This will be regarding Unity. So I'm currently within the SteamVR template, but I want to show you a tip regarding how you can quickly pattern objects within a inspector. So over here I have 10 cubes. They're all the default cubes from Unity, which will have the length of 1 meter. And as we can see, they are all overlapped over here. If I will select the first one, afterwards the last one, we have a selection of 10 elements in this case. We're going to see their position on x minus 20, on y 0.5, because I want them to be on top of the ground plane. And now over here for the z-axis, we see the orientation. We can go with a function, so I will type in L. Afterwards, within parentheses, I will type in minus 10, and afterwards 10. And as we can see, this will give us the following linear pattern over here. If I will select the first cube, this will be 10 in this case, and on the opposite side, this will be the original cube. So normal cube, afterwards 1, 2, so incremental, that name has been changed. If, for example, I will select cube 10 and I will copy and paste this with Ctrl-C and Ctrl-V, this will be cube 11. And if I want to snap this over here into position, we're going to see that this will be perfectly snapped over here. So we define that linear pattern for those 10 elements, and they will each have a distance of 1 between them. We can also apply additional functions over here. So, for example, I have over here the following sphere. So this will be the first one, and again I will have 10 of those. Now, if I will add the position for the x, I will go again with L, and I will type in minus 10 and 10. We're going to see the distribution will be like this, so just like previously, but in this case I swapped the x-axis. But over here on the y-axis, I can type in a formula. Let me just make this a little bit larger so we can see it. And as soon as I'm going to click outside that formula, it will no longer be visible, so I will paste it again. So we see the distribution in this case, this will be for a scene graph, as you can see over here. So we have L from 0 to 10, and afterwards we can change the values over here. For example, with 0, 1, and 1 over here, this will be the distribution. And as I increase this value, that wave will change. So the same will be over here. I can also change this one. So for example, if I will go over here with 1 in this case, let me just press F so I can be focused over here. So I will again change this from 0 to 1, and afterwards 0.1, and we're going to see how this will increase like that. If I will change this, this will go into the other direction. So we can control the wave curve over here. So this can help us if you want to pattern the objects within a scene curve like this. And the same can be done with cosinus. For example, over here we see the same range, or I can change it from 0 to 10. And afterwards, if I will go with 0.1 and 1 over here, 2, 3, 4, and we're going to see how that will slightly change. I can go all the way over here to 9, and again 1, 2, 3, 4. And we're going to see how those will pattern over there. I can also change this to a tangent, and with a tangent we're going to have the following distribution. Again, I will paste it again, because if I'm going to click the viewport, this will no longer be visible. So I can type in over here with 2, 3, 4, and again if I will go from 0 to 1 over here, we're going to see the following output. With 5, that will go a little bit higher. With 6, it will go like that. With 7, we already see it 1 from the bottom. And if I'm going to increase this to 2, we're going to see how that wave will change. So this is a nice tip and trick regarding the defining of patterns within Unity. I think that the most useful is this one, because we can do a linear pattern really easy like this, so we can have the elements distributed. But we can also change this, for example. But in this case, if I'm going to add the sinus function over here, it's important to also have the distribution done on x in this case. Because otherwise, if on x I will leave it with 0, if I will go over here, we're going to see that this will be the final output, since we don't have that L distribution added to the x value. But as soon as I will add that, we're going to see how it will change, and we can start defining that sinus distribution for those elements. Okay, so I hope you enjoy this kind of content. I will position a similar video over here on the left side, and I will also add a subscribe button to the right. So that's it. Thanks for watching.